Welcome to this explainer. If you've ever looked at a complex medication order and felt a sudden wave of anxiety over the math, well, you are in exactly the right place. Today, we're going to demystify the entire process of pharmaceutical dilutions. And the best part, I'm going to prove that you actually already possess the foundational logic you need to master this whole thing.
Here's our quick roadmap for today. We'll start with intuitive everyday dilution, jump into the golden rule of math, look at working with stock solutions, and finally, we'll wrap up with the magic of alligation.
Section 1. Intuitive everyday dilution. Let's prove that you really do already understand the core logic of pharmaceutical chemistry.
Think about your morning routine for a second. How do you fix a cup of coffee that's just way too strong? You just add a splash of hot water, right? It's instinctive. And when you do that, you intuitively know that the actual amount of the active ingredient, the coffee grounds, remains exactly the same. No extra coffee was added, and none was taken away. Literally, the only thing that changed was the total volume of the liquid getting larger, which makes the final drink less concentrated. That exact same logic is the bedrock of pharmaceutical dilutions.
In pharmacy terms, that extra water you added to your coffee is what we call a diluent. It's just a substance added to a product to reduce its strength. Crucially, a diluent usually has zero active drug substance in it. So think sterile water for injections, or even an inactive base like petrolatum for mixing ointments. It's a completely essential building block for prepping medication safely.
Moving right along to Section 2, the golden rule of math. Let's translate that everyday coffee metaphor into actual, usable numbers.
Okay, this equation right here, this is your ultimate cheat code. Q1 times C1 equals Q2 times C2. Let's break that down. The first quantity, Q1, multiplied by the first concentration, C1, will absolutely always equal the final quantity, Q2, multiplied by the final concentration, C2. Because remember the coffee? The total amount of active drug never, ever changes during a simple dilution. The left side is what you start with, the right side is what you end up with. Same amount of drug, just dispersed in a different volume.
Look at how perfectly this illustrates the inverse proportion we're talking about. Imagine starting with a volume of 50 milliliters at a 20% strength. That means you have exactly 10 grams of active drug. Now, if you add a diluent until the new volume reaches 100 milliliters, what happens? The volume has exactly doubled from 50 to 100. And because those 10 grams of active ingredient didn't change at all, the strength absolutely has to drop by exactly half, going from 20% straight down to 10%. It's an inverse rule. Volume goes up, concentration goes down.
Section 3. Working with stock solutions. Let's take this into the actual pharmacy and see how it works in practice. Manufacturers prepare these strong, known concentrations, like this vial of folic acid, specifically for convenience. This is a classic stock solution. You see the concentration is 5 milligrams per milliliter. Now, a pharmacist is almost never going to give a patient this entire vial at full strength. No way. Instead, they use this highly concentrated stock as their starting point. It's their Q1 and C1. They use it to calculate and dispense custom diluted doses for individual patients. Here's another everyday example for you, a solute vial. The label clearly says there are 100 milligrams in a 2 milliliter volume. Just like the folic acid, this concentrated hydrocortisone stock has to be incredibly carefully measured and diluted to hit the exact, usually much lower, concentration ordered by a doctor. So the takeaway here is that reading these labels literally hands us the puzzle pieces we need. You extract the exact milligrams per milliliter right off the glass. Folic acid is 5 milligrams per milliliter. Solute simplifies to 50 milligrams per milliliter. Once you have those starting concentrations, you just plug them directly into our golden rule formula. If a doctor orders a specific final volume and a weaker concentration, you plug those in as Q2 and C2 and just solve for your unknown. It totally removes the guesswork, which is absolutely crucial for patient safety.
Finally, Section 4, the magic of alligation. Because you know what happens when you aren't just adding 0% sterile water. What if you have to mix two different strengths of an active ingredient together to hit a totally new intermediate target strength?
Well, enter the magic of the alligation alternate method. This is essentially a brilliant visual tic-tac-toe game that turns a messy, headache-inducing algebraic equation into a super simple visual puzzle. The rule is just that the strength of a mixture has to lie somewhere between the strengths of its components.
Let's break down exactly how you use this tool. Step 1, put your desired target strength right in the center box. Step 2, put your stronger available stock on the top left and your weaker stock on the bottom left. Then, and here's the trick, you subtract across the dashed diagonals. Just always subtract the smaller number from the larger number so you get a positive result.
Step 3, read the results horizontally, straight across from left to right. That tells you the relative parts of each component you need.
Let's actually do one together. Say we need to make a 70% alcohol solution, but we only have 95% stock and 50% stock sitting on the shelf. We drop our target, 70, right in the middle. Top left gets the 95. Bottom left gets the 50. Now, subtract across those diagonals. 95 minus 70 is 25. Put that on the bottom right. Next diagonal. 70 minus 50 is 20. Put that on the top right. Now read it straight across. The grid tells us we need exactly 20 parts of the strong 95% alcohol and 25 parts of the weaker 50% alcohol. Add those up, and your final mixture has 45 total parts. From there, calculating exact milliliter volumes for any batch size is a breeze. See? It literally turns complex chemistry into basic third-grade subtraction.
To wrap up this explainer, I'm going to leave you with a real-world logic test based on our golden rule. A technician gets an order to prepare 3 liters of a 50% alcohol solution. But, looking at the shelf, they only have 1 liter of 70% alcohol available to use as stock. The tech calculates that they can only fill about half the order. But, did they calculate that correctly? Using your intuitive understanding of active ingredients and that Q1 times C1 rule, do they actually have enough active drug to dilute, or do they need to order more supplies immediately? I'm going to let you run the numbers. Keep practicing with these visual tools, and I promise those intimidating calculations will become total second nature. Thanks for watching.